All right, welcome back, fourth graders. So for this tutorial, I want to see if I can help clarify how do you tell if a number is considered prime or if the number is considered composite. So I'm going to start with the composite numbers because I think composite numbers are easier to identify for some reason. So if you read, it says composite numbers are numbers that have more than two factors. So if you remember, factors are two numbers that you multiply to get a product. Or if you go the opposite way, if you take a number like a multiple and you want to divide it, how many different numbers or factors can you divide it by and get a whole number as your quotient or your answer? So I'll show you what I mean. Like, let's look at a fact family first. That might help kind of clarify things. So let's take 2 times 3. 3 times 2, we know that 2 times 3 is 6. 3 times 2 is 6. Now, if you start with 6, you can divide by 3 and you'll get 2. And 6 divided by 2 and you'll get 3. Also, I forgot, you could also do 1 times 6, right? That also equals 6. And then you can do 6 divided by 1, that'll equal 6. So the number 6 has a lot of factors, right? If you look at the number 6, you can divide it by 3, you can divide it by 2, you can divide it by 1, you can also divide it by 6. I forgot that. 6 divided by 6 equals 1. So if you look at the number 6, it has 4 different factors. And if you have to ask yourself, does it have more than 2 factors? Well, yes. There's 4 factors that the number 6 has. So the number 6, so we say that 6 is composite. So anytime you get a number where there's more than 2 factors, it is called composite. Let's look at another example. Maybe I can list them out in a way with a little more clarity. Hold on, let me get rid of all this. Let's take the number 8. Let's look at the number 8. So here's the number 8. So again, you can do 1 times 8. You can do 8 times 1. You could have 2 times 4, or you could have 4 times 2. So just by looking at those factors alone, right? You've got 8 you can go 8 divided by 1. You could go 8 divided by 8. 8 divided by 2. And you can go 8 divided by 4. That'll be 8. That'll be 1. See, all these quotients, all the answers are whole numbers. So we just count them up. Let me circle a different color. So you've got 1 factor, 2 factors, 3 factors, and 4 factors. So again, because there's more than 2, we said that 8 is composite. And as long as there's more than 2, then the number will be composite. It can be 2, it could be 3 factors, it could be 4, it could be 10 factors. Because the larger the number gets, the chances are the more factors you're going to get. Let's try another one. Let's look at one that has an odd number of factors. Let's take the number, let me think here. 25. Let's look at the number 25. So the first thing you might think of is 5 times 5. That's fantastic because 5 times 5 is 25. You could also do 1 times 25. So now what we have to do is we have to kind of test it using the divisibility test. Well, 25 divided by 5 is going to equal 5. That's good. 25 divided by 25, that equals 1. And 25 divided by 1 will equal 25. Oops. So now we just go circle. How many factors does 25 have? Well, it has a factor of 1, factor of 25. But look, you have 5 times 5. But you can't use it twice. You can only use it once. We're not allowed to use the same number twice. So 25 has 3 factors, right? 1, 2, 3. So we say 3 factors. And even though it's just barely more than 2, it's still, it's greater than 2. So 3 factors, that makes it composite. Remember, any number that has more than 2 factors is considered composite. So then let's take a look. Let's go over to the other side. What makes a number prime? Well, prime numbers are kind of special. There's a lot of them, but they're kind of special in that they have to have exactly 2 factors. They can't have less and they can't have more. Because remember, if they have more, right? If they have more, that's considered composite. But if they have exactly 2, that's considered prime. Let's look at an example. Let's look at the number 2. The only numbers I can multiply to get 2 are 1 and 2, 1 times 2. And then if I check the divisibility using the divisibility test, right, I can do 2 divided by 1, that's 2. And 2 divided by 2, well, that's going to be 1. I can't use anything else. So the only 2 factors are 1 and 2. So the number 2 is prime. Let's take a look at another example. Let's look at the number 3. Okay, again, I can multiply 1 times 3, but that's about it. I could do 3 times 1, but the factors didn't change, right? I changed the order, but I didn't change the factors. I still have a 1 and a 3, and that's it. And from there, you can go, what, 3 divided by 1 or 3 divided by 3. So if I can only have 2 factors, then this is also considered a prime number. Let's take a look at some numbers that are a little bit larger, but they're still prime. Let's say, for example, we have number 11. 11 is a good number, right? You can do 1 times 11 or 11 times 1. Now remember, it's still the same factors, 1 and 11 or 11 and 1. The only thing that's different is the order. But they're still the same 2 factors. So 1 factor, 2 factors only. 1 and 11 are the only 2 factors you can multiply and get 11. And using the divisibility test, if you divide 11 by 1, you get 11. If you divide 11 by 11, you get 1. So whenever you divide, your quotient has to be a whole number. Let's take a look at one more. Let's take one that's a little bit larger, but still prime. Then I'll show you a chart where you can find all the prime numbers. How about the number 29? I can multiply 1 times 29 or 29 times 1. So if you think about it, 29 is an odd number, right? So it's an odd number, so I can't use the number 2 as a factor because 2 is even. I can't use 4, that's even. I can't use 6, that's even. I can't use 8 or 10 or 12 or 14. And 14 times 2 is 28. So I can't use that one because 14 and 14 is 28. I can't use the number 3 because 3 times 9 is 27. 3 times 10 is 30. So we can't use 3. I can't use 5 because anything multiplied times 5 has to end in a 5. I can't use 7 because 7 times 4 is 28. Oops, sorry. 7 times 4 is 28. 7 times 5 is 35. So I can't use 7. I can't use 9 because 9 times 3 is 27 and 9 times 4 is 36. So you can see I'm trying to use all the possible numbers to find factors, but unfortunately 29 only has 2 factors. It only has 1 or 29. So because I can only use those 2 factors and multiply them to get 29, then 29 is considered prime. So you've got more than 2 factors, composite, exactly 2 are considered prime. What about numbers that are neither. What do we do with numbers that are neither? Numbers that are neither prime or composite. Well, there's only two, thankfully. I bet you could probably, if you're watching this, you can probably think of the two that I'm thinking about. The first example is the number 1. What do we do with the number 1? Well, the only way to get 1 is if you multiply 1 times 1. But what do you notice? They're the same. 1 and 1 are the same, so the number 1 has only one factor. Okay, it has only one factor, just the number 1. So remember, if a number is prime, it has to have exactly 2. If it's composite, it has to have more than 2. Well, the number 1 only has 1. So we say it's neither. Then what do we do about this number? Look at the number 0. What do we do about 0? Well, 0 represents nothing. So if there's nothing, there's no factors. So 0 has no factors. Nothing can't have something because it represents nothing. So no factors for 0. And we'll just give it a big 0 with a frowny face. Sorry, 0. Nothing for 0. Okay, so here, let me provide you hopefully with a chart. So if anybody ever needs this, I'm sure I'll make this available. But I have a chart that will show you. I have actually I have two. This one I just found. So you can see from 1 to 100, this chart will list all the numbers that are gray are the numbers that are prime. And you can see that here. So if you want to figure out, you can take each one if you wanted to and you can practice, but remember 2 only has 2 factors, 3 has 2, 5 has 2, 7 only has 2. All the numbers that are gray are considered prime because you can only multiply 1 times that number to get there. If a number has more than 2, like these guys, they're going to be considered composite. So all the ones in green are considered composite. And you can go through and mark up the chart if you want. Remember, the only one that is neither is our friend here on the right here. This one is neither because poor number 1 only has one factor, so it's neither. So it's not prime, it's not composite, it's neither. It's just 1. Okay, so please reach out if you have any questions about what the difference between a prime number and a composite number is. And my best suggestion is, if you're unsure, is to use a chart. You can use this kind of chart or a multiplication chart, and you can figure out, you can go make up your own and you can mark off the ones that are prime. So you know, if you have a quiz or a test and you need to know, you can use the chart. All right, thank you. See you soon.